All right, and I'll hand it over to you then, Safwan.
All right. Thank you, Dixon. So welcome everyone. In today's session, we will be doing this briefly introduction to ZenML, how you can start with it, install it, and run some simple pipelines for the beginners. We're a bit sorry for people who have advanced pipelines in cloud and stuff like that, but feel free to ask any question you have or anything that you think will help you in the future. So first thing, let me share my screen. All right. So my name is Safwan. I am a junior machine learning engineer here at ZenML. And this young dynamic team that spreads across the world, each of the team have previous experience trying to deal with machine learning deployment in production. And that's exactly why we are working together to build this open source framework that tries to solve these problems, problems that everyone faces when we want to move from machine learning model and experimenting in our local machines into a production level. And the first thing we need to talk about is that now MLOps actually trying to solve a lot of problems with machine learning, but even though it tries to do that, it's still a broken process. And I could see two main reasons for that. First one is the huge landscape of tools in MLOps. There is a lot of tools, and each tool cannot cover everything. It only covers one part of that MLOps process. And the second thing is the different roles. So for example, we have data engineers, software engineer, and product managers who deals mainly with data and stuff like that. And then we have data scientists who deals with experimenting and modeling, stuff like that. And then at the end of the flow, we can see MLOps engineer and ML engineer who tries to productionalize the models and deploy the models and do the maintenance. And this actually what makes it a bit challenging to work with. So the way to solve all these problems and sort of make it much easier, we need somehow to create or implement a unified interface. And doing that is by abstraction to the right level for the data scientist. And we should have this one way that everyone in this flow can understand, from domain experts to product manager, without having different ways which can sort of create a gap between them. And creating this unified interface is a bit complicated because for one simple reason, there is a lot of components in the MLOps. And for example, there is the code repo, which is usually the actual modeling. And we have something called orchestration, which is where we're gonna run this model and how it will be run. We have model evaluation, metadata store, or experiment tracking, so to track the hyperparameter and everything. And as you can see, there is a lot of components. So in order to solve this, ZenML is an extensible open source framework to create a unified pipeline interface for MLOps pipeline. And what does that mean exactly? Simply tries to connect or glue these all components together in an architecture where we're going to use something called pipelines and stacks. That's mainly the idea. So in order to do that, ZenML is built around two things. The first one is ML pipelines, which is pipelines are a set of processing elements connected in a series in ZenML pipeline, which is list of steps connected together. And the second thing is a stack, and stack is the underlying configuration of infrastructure and tool. And we're gonna see in future, in the next in the code and the example, that ZenML actually tries to integrate different tools together in order to keep the configuration of this tool together in one place, and easier to modify or update or anything like that. We need this logic called MLOps stacks and MLOps stacks components. And now that we know that MLOps ZenML is all about pipelines and stacks, let's see a bit how does architecture of ZenML looks like. And as you can see, we have data scientist and ML engineer, which usually responsible for pipelines, creating and writing pipelines. And then we have either cloud engineer or DevOps engineer, which usually responsible for cloud and infrastructure. And then in the middle, we have this thing called ZenML server, which like connects everything together. So once data scientist and ML engineer will write their pipeline, and like DevOps engineer will create this infrastructure for them, they can just use that configuration that DevOps engineer created to run their pipeline. So like they don't need actually to understand what exactly is going on. For example, if I wrote a pipeline and I want to run it in a cloud, either in Kubernetes or Kubeflow or any other orchestrator, I don't need actually to understand that orchestrator. DevOps team will configure it and create the infrastructure, and they have just to write one pipeline that everyone can understand. And then like, let's set some of the known limitation that we are working on solve. First thing, like starting from ZenML 0.20.0, which is like the major break change that gets at like Zen server and dashboard and everything like that. There is actually some bits of like, there is some stuff that are not really done yet. And like you can find more about this in our roadmap, but like mainly ZenML right now works on Python 3.6 to 3.9. And like other thing is per step Docker build, which is like there is this sort of orchestrator thing in ZenML that can build a Docker image for each step. It's like the team working on it, and like it will be available soon. Also like hyperparameter tuning, while you still can do hyperparameter tuning like by doing customized code in your steps, you can, there is no actually integration for the hyperparameter tuning like experiment tracker or deployer or other tools like that. And like the final one is conditional step and early stopping pipelines. And now let's sort of like see some of the most asked questions. The first one is ZenML a pipeline tool or an orchestrator like Kubeflow, Airflow, Flight, if you have heard about this tool before? And like the simple question, like not really, because like ZenML actually what tries to do is connect this orchestrator together and let you run your pipeline in those orchestrator, and actually like not sort of like take place of them. And can I use tool X or tool Y with ZenML or integrate it? Yes, of course you can. Like while we have more than 30 plus integration in ZenML, you can still, if you feel like your tool or like your preferred tool is not part of these tools, you can always integrate it. And actually like there is a great documentation that team puts together to explain like in a simple way how you can integrate new tool and like use your tool with that. And also like we will be very grateful to have your contribution to ZenML since it's on open source, and we will be happy to help you on doing that. And final thing, does ZenML support the M1 chip processor? Actually, like yes, but in a bit of complication because of like the new architecture. It's only now working with Rosetta, which like you need to run everything with Rosetta, which is sort of like simulation of Intel processor using that M1 processor, but basically you can run it or either use the Docker image. So I think now let's run some pipelines. Okay, I'll go to other screen. And like before starting actually like running some codes and pipelines, is ever anyone here have any question or something like that? Please feel free to ask.
Cool. Everybody seems in tune.
Right. I hope you can see my screen. So now, like, let's start. And like to do that, I'm gonna start like really from this, like from the beginning, and by just doing Python.env by creating a new virtual environment, which I will call, for example, ZenML101.
So one, like maybe I can ask you for one favor.
Sure.
Could you zoom in for the purposes of the recording?
Yeah, sure.
In the terminal. Thank you.
Okay. I hope this looks better.
Yeah, for me it's a bit laggy, but I don't know if everybody else has the same. But I can see it now quite clearly. Thank you.
So after doing that, like we need to activate our tool environment. And let's do that. And like to make it like easier to explain and everything, I actually gonna use like a Jupyter notebook instead of the code that we have here, just because like it looks much simpler and easy to follow rather than codes in like VS Code. And the first thing to do is install book. Like once we have that like installed, we're gonna jump into our navigator and start working on Jupyter notebook. Hopefully that will be done in the next few seconds. Okay, that's done. So now maybe let's run Jupyter notebook. Okay, so this is our quick start notebook. And then let's jump to our notebook. And as you can see, like, okay, maybe let me do this. So not making it confused. Okay, now that we are on our notebook, like the first thing we're gonna start with is like explain what we're gonna show here, which this will be just like, as I said before, quick start guide, which will go through first explaining a very simple pipeline, just to understand the idea of steps and pipelines and stack. And then we're gonna move on to somehow a bit of more advanced pipeline, which starts from training, evaluating, deploy the model, and like do another inference pipeline, which sort of tries to run some predictions on that model that we have already deployed, and maybe see if we have any data drift in our like data between the training one and the inference one. And like, just as I said, the first thing we're going to explain is actually steps. And like for steps is a simple Python interface that tries sort of like makes every functionality process itself that can be like separated from other processes and then used anytime we want it in a workflow or in a pipeline. And like to create a step with ZenML, all you need to do is like from ZenML steps dot steps import step, and then use this thing called Python decorator into your function. And in this example, as we can see, we have like this may data loader, and it returns a data frame. And like decorator, like that will be sort of like telling ZenML that, okay, this will be treated as a step later on. And the second thing we have is a pipeline. And just like step, we have a decorator for pipeline. And like pipeline is a simple interface in Python that tries sort of gather those steps together in order to create a value from it in an order of sequence. And like in this example, my pipeline have two steps, my data loader and then my trainer. The third thing, like the most important, is stack and stack components. And as we said, ZenML, like stack and stack components are the configuration that the pipeline will be run on. And there is like different flavors and different ways of setting this stack and stack components. But let's say that there is two main components, which is like orchestrator and artifact store. And like whenever we want to start a new or run a new pipeline in ZenML, we need to have like an orchestrator and artifact store. And for the other component, they are optional. And like we will see some of them later on this course. For the integration, of course, like just as I said before, there is a lot of integration with ZenML, more than 30. And like we will just focus mainly on two of them today, and like you can check the website to see like the other one, and feel free like to either ask questions regarding that, or maybe if you want your integration to be part of it, you can check the roadmap and add it. Okay, so first thing we're gonna do is install ZenML, just like by doing pip install. So since we want the dashboard and like the new thing that comes with ZenML 0.20, we're gonna do install ZenML server instead of just ZenML. Okay, I think this just got restarted. And now, like, let's start with a very simple pipeline. And in this pipeline, we're gonna import random, and from step, ZenML steps, import output and step. And the idea of this first step is easy. we just want to return an integer. So we're gonna define our function called first step, and in the output, it will be first name, which is an int, and the name of this step, like, and the return is 101, which is like ZenML101. And let's run this step. Okay, second step will be no different, but like the only difference here is just we are trying to get a random int between 0 and like 101. And the third step, it will actually try to subtract the both numbers, like the first number from the second number, and then returns those results. As you can see, like it's very simple to declare a step and like write whatever you want on it. And once we have our steps ready, let's move on to the pipeline and see like how we can gather those steps together into like one sequence or like one workflow, if we can call it like that. And just like step, we have a pipeline decorator, which we should call. And in this pipeline called quickstart first pipeline, we have like 3 parameters, which is like first step, second step, and third step. And then we define that the first step will be using actually like that step that we defined earlier, which like returns 101. And then in the second step, it will return a random number, integer number between 0 and 101. And the third, and for the third step, we're gonna give it the result of the first one and the second one. So let's run this. And like once that's defined, we can call that pipeline and run it. Is there any?
Yes, Safan, I think we have a question in the middle. If you want, I can interrupt you like this so that you don't have to switch tabs.
Yeah, sure. Thank you.
And could you also maybe zoom in here as a little side comment? So we can read it. But Pastor asks, can you repeat what is the difference between installing ZenML with pip install ZenML and using the server extra?
So actually, like when we do just pip install ZenML, we will be just installing the client, which is like uses the SQL, like the Zen store locally without having a dashboard that we can see. And like we're gonna talk about dashboard later on, where we can see pipelines, and also without doing the server, like we can't actually sort of share our stacks with other people in the team. So that's the difference. So the server comes up with sort of like a new architecture that takes the server out of like the same environment we are using, and like make it in the central place that every client, which is like ZenML framework, connects to either like get data or store it and stuff like that, if that makes sense. So like I hope that answers your question. And like as you can see now that we run our pipeline, the pipeline started, like we have the first step here that started, then like second step, and once we did subtract, we have a return value of 71. And like as like first thing that we, and extra thing that we're gonna show here is that let's try, for example, to do run the same step, and like what happened is that we don't have the return value anymore, and that's because ZenML uses caches, so you don't run the same step. That like if nothing changed about the pipeline or a specific step, we will not try to run it again because we have already the cache for that. And as you can see, everything is cached. But like if we did, for example, enable cache equals false, and then we try to run this again, it will give us a new value, which is like we don't have cache anymore for this pipeline. So this is like after like setuping the step and the pipeline, the first thing we see is like how we can enable or disable the cache. But like right now we only, so actually we have run a pipeline and it's working, but we have only sort of discussed steps and pipelines. But earlier we said that ZenML is about 2 main things, steps and pipelines on one hand, and the second thing is the stack. But like, where is our stack in this? And like to explain that, we're gonna run, if you don't know already, like ZenML comes with a CLI, command line interface, which you can use like to see a lot of stuff. And the first command that we're gonna see is ZenML stack describe. Let's run it. And this will give us that by default, when you start a project like in ZenML, just after installation and doing ZenML in it, it's by default like creating this, what we call it, default stack. And it comes with 2 different stack components. The first one is artifact store, and the second one is orchestrator. And like, let's have like more information about artifact store and orchestrator, maybe. And like, as we can see, our active project is default. We have a stack default. And for the artifact store, we are using a default one, which have like a flavor of local. And this is actually like one of the amazing stuff about ZenML. There is a different flavors. For example, if we want not to use our disk to store data and we want to use, for example, an S3 bucket, we can set up that in infrastructure and we will have a flavor called S3 bucket here, S3. And that will like use another storage which is not locally to store all our data related to our running pipeline. And like for the orchestrator, it's similar to that. We have like a flavor which is called local that will run the pipeline locally. And for example, if we have Airflow or like Kubeflow or something like that, or Kubernetes, it will be using the other one with different configuration. So that's the stack. Now, like the second thing, let's try to create an MLOps stack. Sorry, like there.
Dixon, go ahead.
There is a question from the audience here, Safwan, from Mert. It says, this step decorator is just for Python APIs, or can we use also CLI tools? If we can, how?
Sorry, like, is the question, can you create a pipeline without the decorator or what?
Mert,
Maybe
would you like to clarify?
Hello, can you hear me?
Yes.
Okay, so in here you are creating a pipeline, right? For
Yeah.
example, if we are going to use CLI tools, how we can create a pipeline with ZenML?
Oh, you actually like have to create your pipeline using Python code, and then CLI in ZenML is more like some management or like sort of tool that you can do to either create new stacks or do different stuff related to the whole architecture and not actually like creating pipeline itself. So the code of the definition of the pipeline step should be written in the code, if that makes sense.
I got it. Thank you.
Come. So now, like,
There is another one.
Yeah, sure, Dixon.
What is an artifact store in general? Gitan.
Okay, so artifact store is actually like a stack component in ZenML that we are using to store our data. And like it's mainly responsible to store the artifacts, which is like not the metadata and like stuff related to like what was running, but mainly the actual, maybe the data, the models, and stuff like that. And like for ZenML, there is a different implementation and abstraction for the artifact store. So you only need to set wherever artifact store, or let's call it, where do you want to store your data? So if we have a local one, which is like the default, then you are storing it on your disk. And like if we, for example, set an S3 bucket, then all your data will be stored in an S3 bucket rather than the local one. So that's basically, it's where the data is stored related to our pipeline and project. Is there any more questions, Dixon?
No more so far. Thanks.
Okay.
Thanks,
Okay,
Safwan.
Okay, then I guess let's continue with this demo. And like the second thing we're gonna try is actually to create a new MLOps stack. So far what we did is just create a simple steps and pipelines and run them with the local one. But what if we want to create a more, how we call it, like advanced example that somehow like either tries to train, evaluate, and deploy the model, while also keep track of what experiments we have been running, and also see if like we have any data drift or stuff like that. And like to do that, the first thing we need to do is like ZenML integration install. Like ZenML comes with a bunch of integration, and actually there is a simple CLI commands that helps you to install whatever integration you need. And like to do that, let's maybe even do it with like CLI here. So just so you can see like CLI in a better way. So first thing we're gonna need to do is source. Okay, so we are ZenML101, and then activate. Like once this is activated, let's do ZenML, which will sort of like give us like all the output of our CLI is, and as you can see, we have different commands, stack components, and like each of these will help you to configure and like manage each of these stack components, alerter, annotator, and different stuff. Integrations to install new integrations, management tools like to deal with stacks, projects, profiles, and pipeline, stuff like that. And then there is like identity and security for role teams and user, and extra commands which like do ZenML down, go init, and like get the version, stuff like that. And now what we want to do is like ZenML integration, install, sklearn, MLflow, and evidently, which are like the tool that we're going to use in this example. Okay, so all the required are already installed. And now let's go back to like and continue with our creating our stack. And like now to create a stack, this is very interesting because, for example, right now what we want to do is create an MLflow experiment tracker. And to do that, we need to run like ZenML experiment tracker, which is like the command that we saw earlier, and then register. So the command register is like telling ZenML that we're going to register a new MLflow tracker and then give it a name in this like MLflow tracker. And then we have the flavor. So like ZenML can know how to deal with different configuration requires for this exact stack component. The flavor is what telling ZenML like how to deal with it. And like same thing for model deployer. We have like MLflow model deployer, and then the flavor, it will be type of MLflow. And like for here, for model deployer, for example, we could have like Seldon Core or like KeyServe or any other tool. And like the final thing, we have data validator, which will create a new, like register a new stack component with the flavor evidently, which is like the integration. And the final thing, we need to group all these things together, or the stack components together. And as you can see, we have like A for default for our artifact store, O for the orchestrator, D for deployer, E for like experiment tracker, and DV for data validator. So let's run this and try to register all these new components that we're going to use in this new pipeline. So whenever you want to sort of use a new tool or like do something that requires one of the integrations, you need to register a new stack component for it, and then either update whatever stack you have already before, or create new one with this different new stack component. Still registering. Okay, it's done. And like once that is done, we can then, so for example, if we do, okay, let's do something here. So let's do, for example, ZenML stack list. Let's see how many stack we have. Since we just registered a new one, as we can see, like we have two stacks, the default one, which was like by default the one we were using, and we have a new one called quickstart stack, which we just created with like a default artifact store, default orchestrator, and then data validator and experiment tracker and model deployer. Now, if we want to make that new stack the default one that we're going to use, or the active one, we need to do ZenML stack set quickstart, and then let's do that and describe it, maybe to see like what are the components of it. As we can see, like now the main active stack is this new one, and whatever pipeline we try to run from now on, it will be running using this configuration, like this stack, instead of the old one, which had only like the artifact store and the orchestrator. Now, the following thing is like we're going to try to define an email pipelines, which like won't be as simple as the previous one, which had like just 3 simple steps. And for that, we're going to define basically 2 main pipelines. The first one will be called training pipeline, and the second one will be called the inference. For the training, we have like 4 main purposes for it. Like just any simple project, that ML project, we want first to load the data from whatever source. either like from a library or Cargill or something like that. Then we want to train our data, then like do evaluation on that data, and finally we want to deploy. But like to deploy, we don't want just to move on from evaluation to deployment. We want to see if like our training actually and like after the evaluation have better result than an already deployed model. And that's very important. So we don't deploy a model that will, like for example, in the previous experiment, we ran this pipeline and we got 0.8 in the accuracy. But like in the following, we got, for example, 0.7. We don't want to deploy a model with 0.7 while we have another one with 0.8. So that's the idea of the deployment trigger, and it's a very simple like step. And like once the training pipeline is done and like we have a deployed model that's ready to run predictions, we want to execute another pipeline, which we call it inference pipeline. And for this pipeline, we have another data loader, but this time it's called like inference data loader, which will get us a new data that the model have not seen before, and then it will try to give it to the already deployed model. But before doing the prediction, we need somehow to retrieve or like get that model and like make it, we should get all the information related to the deploy model. So for example, if that deploy model is running somewhere, we need to know what address is running at, and that will be doing it using the model picker, which will get us all those informations related to that service or that model. And then in the predictor, we will give it the new data that we loaded to see our prediction. And like there is one extra step here, which called drift detection. And this just to see if we have any data drift between the data we used for training and the data we used for inference. So now I think let's start with this will be a bit different. Now we're going to start actually with the pipeline science. Like we know what we want to do in the whole idea of the project. So we want actually like this flow. That's why we're going to start with the pipeline. And for this, as you can see, we are using the same parameter. We don't want anything to be cached here. So our pipeline will be called quickstart training pipeline. It has a training data loader, then a trainer that will train our model, our evaluator, deployment trigger, and then the model deployer. And then we have a quick start inference pipeline, which have like a data loader for the inference, predictor service loader, predictor training data, and drift detector that we saw earlier. Now let's start implementing steps. And as you can see, the first step is data loader. And for this, we're gonna use like the iris dataset from sklearn. And let's talk a bit about the definition of this step. So first we import NumPy pandas and then sklearn for dataset, like to get our iris dataset, and then the train test split function that splits our dataset between like xtrain xtest and like ytrain ytest. And then of course we need ZenML steps, outputs, and step. And like in the definition, what we can do is like give this step. We know that we want to get from this step like the training test and like Y training and Y test. So the first thing we're gonna like load data into this object iris and then split it into this fourth part. And after that, this function will return this xtrain, xtest, Y train, and Y test. And like for the inference, it's actually getting one row of this data randomly that we will be trying to run a prediction on it. That's basically what it's trying to do. So it's just like similar to this, but like right now, just with one row instead of the whole dataset and everything like that. And like now that we saw the data loaders steps, let's talk a bit about the model trainer. And for the model trainer, we're gonna actually use like sklearn SVC, which is a class of the implementation of a support vector machine in sklearn. And like to do that, we know that our trainer will be getting an xtrain, which is a pandas data frame, and an Y train. But like there is a new component here that belongs like to the way ZenML does this, which we don't want only to train our model, but we want to use MLflow. And like for those who are not familiar with MLflow is a tool that give you some sort of like a central base where you can see your experiments and track them. So we can see what different hyperparameters were used for this exact run. And that will help us to get like exactly what are the best hyperparameter we selected in this run, and like what are the others that we selected in the other run to get the best of the result. And like to do that, we need to call our client, which is like the ZenML installed in our machine, and then get the active stack that we talked about it earlier, and then get the experiment tracker, which is like part of the active stack. And then in the step decorator, as you can see, like in a step decorator, we can give different parameters, like, and based on those different parameters, actually, like ZenML knows how, like, to build that step in a different way with however we want. And in this example, we have an experiment tracker, which means like this step will be using an experiment tracker, and like this one MLflow functionality will make sure that we log everything related to this one. So that's our trainer. And then the following thing is like model evaluator and deployment trigger. And for the model evaluator, we are just trying to get the X test and Y test, and then run score and return that score on it. And for the deployment trigger, actually, after running the score on the test set, we want to see if that score is bigger than 0.9 or not. If it's not, we will not try to deploy our model. If it's yes, then we're going to deploy our new version of the model. And like the final two steps, or actually like before the final ones, model deployment and drift detection. The model deployment, and this is a good thing, it's already implemented. You don't need actually to write anything to deploy your model using MLflow, because we have already built that for you. And like ZenML will detect that there is a model artifact that was trained in the previous step and tries to deploy it. And for the drift detection, it's similar, like there is a built-in step for that. Prediction service loader and predictor. Those are our final two steps to explain. And like we have prediction service loader, and because actually like our trained model does not actually belong to ZenML, but it's like a model that is sort of deployed in our machine, and MLflow who deploys it, we need to create some entity which called a service. So a service is a long-lived thing that we still like have in our machine. It does not stop after finishing the pipeline, because like we need our model to keep running prediction after the pipeline of the training is done. And for ZenML to handle all that, we have created this thing called service, which keeps track of like what exact model is still running and like available to run prediction. And that's exactly what prediction service loader tries to do. It's trying to get that exact model that is still running, and like it was trained using this pipeline called quickstart training pipeline, and using this step name called MLflow model deployer. So whenever we are deploying new model with a different pipeline, we can always get it like using a function like this. And for the predictor, we just running like we have a service start if it's not starting, and then we just run service.predict on our new data and return the result. Is there any question?
Yes, someone. There's a question from our friend Pastor. Pastor said, I saw some examples that use other pipelines besides training and inference. Can you explain for what other purpose can we set a different pipeline?
Yeah, like pipeline is not limited to training or inference. We can like define our pipeline to whatever idea we have. For example, if we just want to transform some type of data, or even create a pipeline that connects with one of the integration we have, which is called Label Studio. We are using computer vision to create a pipeline that will start from loading the data into goes to like a Label Studio to annotate your images and return them back and somehow send them into this storage or send them somewhere. So a pipeline is not related to inference or training. It's like some general thing that you can use for any workflow you think that will be useful, either for your competition or for your project. I hope that answers your question. So now I'm not sure, like I was running every one of these steps. Let's make sure we run them. Now that we explained all the steps, like and what every step does, and why do we need it, the next thing we need to do is actually like run this pipeline. Okay, so we didn't actually run the first one, which is like the definition of the two pipelines. Okay, now it's defined. Let's run. Okay, let's start running. as you can see, in the training, like for the training accuracy, we got 0.9.2, and for the test, we got 0.9.6. And after like evaluator and deployment trigger, this deployment trigger will goes right because like our test accuracy is more than 0.9. This will allow the MLflow model deployer step to work, and then like now we have our model deployed in this address that we can run prediction on it. And like another good part of ZenML CLI is that you can actually see what are the models that are deployed. And as you can see, we have this model. It's active. It has a new ID. It was deployed by running this pipeline called quickstart train pipeline and this step exactly. So we don't need actually to describe it. It's like it will give you, using this command will just give you more information related to this exact pipeline. And like now we want to run our inference pipeline, and inference pipeline, as we said, it will try to load an inference data, load the service loader, which is like our model, and then give the new data to the model and see the result, and finally do an extra step called drift detector to detect if there is any drift between training and like load inference data. And like now that's done. And by the way, like our prediction returns 1. So now let's move on from the pipeline itself and let's inspect the outcome of what have we done so far. The first thing is dashboard. And like for people, okay, so I think we have some problem. Or we have some problem related to the port. We like see this thing. Sorry for this inconvenience.
So fine, for your convenience, I give you the command to kill the port. Maybe I'll use it. I sent it on the Hangout chat.
Okay, thank you. Now let's try to do ZenML app again. I think that port was already taken. That's why we didn't manage to start the dashboard. So once that port, okay, great. So once that port was killed and not like taken by any service anymore, we can actually see our dashboard. And like once we copy that address and go to the dashboard, I think we have something. I think there's some problem related. This is weird. I think I will just like, yeah. Sorry, Hamza. Do you have any idea?
I think the state of your machine is wrong. So maybe if you can open an incognito window and go, it might work.
Okay. What if I tried to do? So this like it can detect.
I think it's more about the cookies. I've also had this happen sometimes when you use development environments. So maybe you can there's a few things to do. Either you can clear the cookies, yes, but I'm still not sure whether that clears the in-memory.
Yeah, I did not.
Like what could help maybe, Safan, is if you do like open an incognito window just to quickly test it. So Control-Shift-N.
Oh, actually, like I'm not sure. What's the alternative commands in the Mac for that?
Command-Shift-N probably.
and shift, command shift, and
Mm-hmm. And this might open new private window in your, if it's Chrome, yes.
okay, let's just do it. Okay, so this one.
Yeah, this you can also do if you maybe try it now.
I think another okay, I don't know, like this is, I think this is one of the good part about doing a live presentation. Stuff like
I think it's a lot to learn if we debug this now.
actually,
Yeah.
but like I will
Yeah.
talk a bit about other stuff that people can do and then go back to this one. And but I think we already have a dashboard that's like sort of running in
Yeah.
a cloud, so we can show people that. And like basically the dashboard is all about seeing your stacks and pipeline in one interface, as you can see in this like in this image, this GIF. And like hopefully I can show it later on with another dashboard. But after that, what we want to do also is actually, oh now, because now like we have restarted this one, we need to sort of rerun this. Let's do that. Okay. Once this is running, okay, now we can see that like our drift is detected, and like actually evidently, which is an amazing open source tool that you may want to check if you want to do like anything related to drift detection. It says that like it detects we have 3 drifts in petal length, sepal width, and like petal width, and there is another like a lot of functionalities in evidently that you can check from their official websites. And after that, we want actually to see like our MLflow experiment tracker. Okay, so this is the MLflow interface, and as we can see, we have run 2 pipelines. The first one was earlier, and like second one was just right now. And if we click on one of these pipelines, we can see the different parameter used to train this pipeline and the different result, the matrices like that we had like after training. So like after that, I just want to mention 2 main things related to ZenML, which is like the first one is the ZenML server on cloud and the dashboard. And what we have done so far is like having the server, the client, and the dashboard in one single machine for one user. But actually for the teams to collaborate together and stuff like that, we can actually do another server, which is like in the cloud. So everyone in the team can connect to the same server, which then connects to whatever infrastructure we have to run the pipeline on it. And to do that, like there is an easy command to do it, which is like just ZenML deploy and follow the instruction, and that will deploy the model for you. And also like there is, once that is deployed, we can actually, let's see if this is available. Okay, so actually like we have another, let me just this one. Okay, so here's our dashboard. I think there is something related to the environment, like what I have been testing before, but basically this is how it looks in the dashboard. And if we go in the stack components, actually like we have 2 different stack components for 2 different users, because like once I tried to deploy this dashboard in the cloud, I did it with the default owner, like default user called and the owner. And actually, if you go to the settings and then into the project, you can invite other members of your team. And like once a stack is defined, let's try something maybe. That would be a great thing to test if we did something like this. Oh, so now let's try to rerun this again. Like, because we have changed our server, which has like all the information. If we went back to this exact code and we tried to do, let's try to register a new stack. So in this new stack, actually, we want other users in our team using the new server and dashboard to be able to access and run their pipeline using it. So it's getting executed right now. It's now registering the MLflow model deployer. Okay, and like once that is done, we will make sure to see like how it's going. But other than that, like the other thing besides like the Zen server, which can allow like people to collaborate between them, especially for the teams in the competition, there is this other thing called the MLOps stack receipts, and like for the cloud infrastructure. So as we say so far, like you can run the stacks like locally. Usually, this is what we did. But for some, like there is times where we want, for example, to run our training using a GPU in AWS or GCP. There is a stack component in ZenML called step operator, which will allow you to do that. And like, instead of actually taking the responsibility of setup in the cloud and everything, like all the resources you need in the cloud, actually ZenML provide a command that will do everything for you. So actually, like there is a list of stack recipes. That's how we call them. And like shout out to Jayash for working on this. This is actually one of the amazing projects I have seen ever. And what it tries to do is sort of combine in the cloud whatever tool you want. So for example, if we want to use a Kubernetes orchestrator or like a Vertex AI orchestrator, and then somehow use a Vertex machine that have GPU and then deploy into KeyServe with just like this one command, ZenML stack recipe deploy, and give it the name, you can actually like ZenML will take care of everything and making your stack ready and connect it to your client, so you don't have like to deal with all configuration stuff. Now that's like, I believe that stack should be registered. Let's see. It's not. Oh, and actually, like we are already on time. So please feel free to ask any question related to this. And like, sorry for this thing related, it's still registering. Sorry for this thing related to the local dashboard. I think I have some problem in my machine. Like, hopefully, like you have somehow like understand something here, and like you have some questions to ask, if there is any. Thank you so much. And like, this is our new stack. Just like it was registered, and this stack now can be shared with anyone in the team, like so they can use it themselves. For one final thing, which is like for the presentation itself, you can actually, okay, so you can actually like check the documentation if you like, where you will find everything related to what we did so far. And also like to understand more about MLOps, you can also like join our Slack channel and like go to the competition 22 and like ask whatever question you have. You can also check ZenBytes, which are like some sort of crash course related to MLOps in general and ZenML in particular. And also ZenFiles, which are other projects built with ZenML. Thank you so much for your time, and like I hope you have enjoyed this.
Safwan, there's one question from Pastor. Pastor was asking, he tried to follow the steps on the README file of the quickstart example, but he ran into the issue that the stack already exists.
Yeah, actually, like I wouldn't. That's not an issue because like that stack already exists. Either you would want to create a new stack and run on it, or even like if it's using the same component, you can use the same stack to run. So that just you can just ignore that error and like run your pipeline, and that wouldn't be a problem actually, because like you just have the same stack already before in your machine. Is there any other questions?
All right, looks like everyone is good. All right, just like Safwan said just now, if you have any questions at any point during the competition, or if you're not even in the competition, just feel free to drop your question in the Slack channel. We'll try our best to respond as fast as we can. And I really hope you guys will have a good journey in this month of MLOps, and see you around. Thank you. Thank you, Safwan. Thank you,
Thank you
everyone.
so much.
Thank you, everyone.
It was very great for me, I think.
Also for me, thank you so much.
Really
Bye-bye.
happy to hear it. Thank you. Have a good journey.
Have a good day.
Bye.